Hello everyone, welcome to the session on hydraulic motors. Myself, Professor Kishan GS, Assistant Professor, Department of Mechanical Engineering, Maharaj Institute of Technology, Mysore. So in this today's session, we are going to study the construction and working of different types of rotary actuators. So before understanding the concept of the construction or working, let us understand the prime aspect of an actuator or rotary actuator. See here what happens. The hydraulic energy which is present in the fluid is converted into mechanical energy in the form of rotation. Therein, the torque is taken as output, yields to the concept called as rotary actuators. So it is the inverse working principle for that of the hydraulic pumps. Okay. So here we have three categories to be studied. One is on gear motor, another one is on vane motor, and the last one is on piston motor. Since you people are already understood the concept of the construction of a hydraulic pump, so the construction remains same except the working principle which is inverse to that of hydraulic pump. Okay, here please make a note of it. Hydraulic energy is converted into mechanical energy. So to understand the construction of external gear motor, we will be having two gears which are meshed at one particular point covered by the casing, and there will be two openings, one for the inlet of fluid, another one for the outlet of fluid. So here what happens, a highly pressurized fluid enters into the casing or enters into the external gear pump, wherein that pressurized fluid results in the rotation of these two wheels. Okay, so these are the points wherein the wheels or the teeth in the wheel receive maximum pressure that results in the rotation of wheels in the entire body. So the rotation of these wheels are extracted in terms of torque output that yields to the mechanical energy as output in the system. Since the gears are externally meshed and the rotation in which the gears are being observed are along the opposite direction, the pressurized fluid is the main source that results in the rotation of these two wheels. The rotation of these two wheels will be connected to an external shaft wherein which the torque is derived for any practical purpose or any useful work at the end. So ultimately, the rotation of wheels yields to the development of torque, and that torque will be considered for any useful work in case of external gear type of motor. Similarly, when we take vane motor, so again the construction remains same. We will be having the cam ring, a rotor which consists of multiple number of vanes, inlet and outlet. Here what happens, the rotation of the rotor is what to be focused. Okay, so through the inlet, highly pressurized fluid will be entering into the system that rotates or tend to move the vanes which are present inside the entire assembly here. So thereby what happens, when the vane tend to rotate, these vanes are nothing but the slots which are available in the rotor, and due to the rotation or movement of vane, the rotor tend to rotate along clockwise direction here as per the constructional principle. So this rotation of rotor along clockwise direction is due to the highly pressurized fluid or the hydraulic energy considered into the system that is yielding to the rotation of rotor. It is nothing but the mechanical energy in the form of torque is obtained here, and thereby you are going to consider the torque which is obtained due to the rotation of rotor for any particular useful work. Okay, so ultimately the hydraulic energy is converted into mechanical energy. Here the rotation of rotor is the output, and rotation of rotor is due to the movement of the vanes, which are nothing but the radial slots available in the rotor that tend to move along clockwise direction due to the pressurized fluid which is being entering into the system. Okay, so similarly we have one more category of motor to be studied, that is piston motor. So as we know, in case of pump, we again here have two types of piston motors. One is bent axis design, another one is swash plate design. So we use the word called as bent axis because the axis of the cylindrical block is at an angle to the axis of rotating of the drive shaft, which is going to rotate along a particular direction that is used for any useful application. Whereas in case of swash plate design, the axis of rotation of the cylindrical block is same as the axis of rotation of the drive shaft. Now let us go with the working principle or understanding of the construction and working principle of different types of piston motors. Keep in mind, when it comes to motor, it is hydraulic energy being converted into mechanical energy, whereas when it case of pump, it is mechanical energy getting converted into hydraulic energy. Okay, so since we are concentrating on motor, so we are going to work on that particular principle of hydraulic energy into mechanical energy. So here, when it comes to the constructional principle, here we consist of the entire piston motor of bent axis design consists of a cylindrical block which is bent at an angle of theta with respect to the horizontal reference or the axis of rotation of the drive shaft. Okay, so the cylinder block consists of multiple number of pistons which are arranged such that the rotation of pistons along a particular direction in the cylindrical block is achieved due to the motion or due to the input, that is hydraulic energy. So we have input, inlet and outlet which are being assigned here. So when there is a flow of high pressurized fluid into the inlet, that results in the extension of piston from one end to another end, that leads to the transfer of rotation of the shaft which is connected into the system here. Okay, similarly what happens once it rotates, that particular hydraulic energy or the pressurized fluid that has resulted in the rotation of shaft, that will be taken out of the system. So here the main task or main term which is to be considered is nothing but the movement of piston at an angle with respect to the rotation of shaft wherein the output is being received. Okay, so here the pink color representation goes with the pistons. Okay, moving on with the swash plate design, the last type of piston motor. Here what happens, instead of giving the inclination to the cylindrical block, we are going to position the piston or we are going to house the piston into an assembly wherein a swash plate is nothing but an inclined plate is being considered as a reference. So here what happens, that inclined plate will be in connection with the drive shaft or the output shaft wherein the torque is going to be extracted. So here what happens, again now the construction remains same excluding the orientation of cylindrical block. Here cylindrical block will be in line to the drive shaft or the output shaft. So again the highly pressurized fluid will be fed through the inlet, that results in the extension of piston, and due to this extension of piston, the piston or the cylindrical block tend to rotate the swash plate, which in turn in connection to the output shaft here, that rotates the output shaft. Once it starts to rotate, the pressurized fluid that has resulted in the rotation of drive shaft will be taken out for the through the outlet once it has created the rotation or once it is resulting in the generation of mechanical energy. So this is something regarding swash plate design. Here the pistons are not directly attached to the swash plate. Instead we have one more plate which acts as a washer like kind that houses the piston, that is nothing but the shoe plate. See, this is the construction and working of rotary actuator. Keep in mind, the main aspect is hydraulic energy is converted into mechanical energy. The highly pressurized fluid results in the rotation of rotating member in the actuator that leads to the rotation of the output shaft, in turn which is considered to be the torque as the output or mechanical energy as the output. Let us now study the next topic in module 2 regarding hydraulic motor, theoretical torque, power and flow rate. See, these are the parameters which assess the behavior of a hydraulic motor. To understand these particular parameters, let us consider a limited rotation hydraulic motor which consists of a single rotating vane. See, this is the rotating element called as rotor, which is housed by a stationary barrier or the casing, followed by a single rotating vane here. Okay, so we have to consider this particular limited rotation rotor to assess these parameters, and let us take the denotions of these particular single rotating or limited rotation hydraulic motor. Okay, so RR being the outer radius of the rotor in meters, RV is the outer radius of the vane in meters, L being width of the motor. So width is nothing but the thickness when viewed from the top, wherein which the entire motor is going to be considered, because that is the area wherein which the fluid comes into picture and rotates the rotating element. Okay, so here the standard units matters a lot when we go with the quantification of the torque, power and flow rate. Hence, we are going to consider all the standard units or SI units here in case of these parameters. So, P being the hydraulic pressure in Pascal, F being the hydraulic force acting on the vane in Newton, and A being the surface area in which vane is coming in contact with the oil, that is in meter square, followed by the torque capacity Newton meter. So this is the graphical symbol for the representation for limited rotation hydraulic motor. Okay, so to begin with, so in order to identify the theoretical torque for the hydraulic motor, so let us consider the force. So the force acting on vane equals the pressure times of vane's surface area. So P being the pressure here and A being the surface area of the vane. So we are going to get F is equal to P into RV minus RR times of L, that is width of the entire motor. Okay, now when we concentrate on the torque equals the vane force times the mean radius of the vane. So this is basically on the constructional principle. So T is equal to P times of RV minus RR into L into the mean radius, that is RV plus RR divided by 2. So upon simplification, we are going to get the torque is equal to PL divided by 2 RV square minus RR. So that is A plus B into A minus B is equal to A square minus B square formula here. So we are going to get the value of torque. Okay. So we do have one more equation to assess the condition in which the torque can be identified. That is, the second equation for torque can be developed by the following relationship for volumetric displacement. So here if we go with the volumetric displacement, Vd is equal to pi into Rv square minus Rr square into L, that is with respect to the limited rotation hydraulic motor here. So using the equation 2 and 3, we can convert the value of T is equal to P into Vd times by 2 pi. See here what happens, the actual torque that will be delivered by the motor will be beyond the value of theoretical torque. Okay, so the theoretical torque, due to all frictional losses and all, we are going to assess, we are going to concentrate this T itself is the theoretical torque. What happens in case of motor is that, see, there will be frictional losses in, that will be a resultant due to the working condition in the motor. So basically, when there is a frictionless motor into picture, so thereby the theoretical torque what we take will be P into Vd by 2 pi. Okay, similarly, the power is going to be considered as the theoretical torque multiplied by N, whereas N should be in radians per second. Okay, N should be in radians per second when we are going with the identification of power. Whereas in case of theoretical flow rate, it is Qt, it is again volumetric displacement into N. So here N should be in revolutions per second. So this is the basic illustration for the hydraulic motor theoretical torque, power and flow rate. Now let us take a numerical on the same principle. Let us take the numerical now. So the question states like this: a hydraulic motor has 82 centimeter cube volumetric displacement. If it has a pressure rating of 70 bar and it receives oil from a 0.0006 meter cube per second theoretical flow rate pump, find number 1 motor speed, motor theoretical torque number 2, and number 3 motor theoretical power. So here, as I already said, it is to be first factor to be considered whenever we are solving the numericals is that to convert everything into standard units. Okay, so 82 centimeter cube is the volumetric displacement. So centimeter cube is also to be understood at centimeter cube per revolution. Okay, so the standard units for the focus is meter cube per revolution. So 82 centimeter cube per revolution, that is given volumetric displacement. Upon conversion, it becomes 0. followed by 4 zeros, 82 meter cube per revolution. Similarly, Qt is meter cube per second. It is given in standard unit. It is 0.006 meter cube per second. That is theoretical, flow rate of the pump here, and followed by the pressure is given, that is 70 bar. So bar should be converted into Newton per meter square, that is into 10 to the power of 5. Okay. So now to solve this particular platform, to identify motor speed, theoretical torque and power, we have the direct substitution of the values into the formula. Okay. So motor speed is N, what we are supposed to identify. We know that Qt is equal to Vd into N. So hence N becomes Qt by Vd. So direct substitution, you will get the value in revolutions per second, because the value of Qt is in meter cube per second, value of Vd is in meter cube per revolution. So meter cube cancels, revolutions come to the numerator, it becomes revolutions per second. It is 7.32 revolutions per second. See here, I suggest you people to go with the usage of calculators, because looking at the board and writing the values is not going to be a feasible solution for you people. So you have to use calculators and you have to learn the conversion of given units into standard units. Okay, so first being N in terms of revolutions per second, followed by motor theoretical torque. We know the exact formula, Vd into P divided by 2 pi. So Vd is known, 0. followed by 4082. Pressure is given 17 to 10 to the power of 5 in Newton per meter square, divided by 2 pi. Hence we are going to get the value in 91.4 Newton meter. So it is the direct substitution as such. So similarly, the motor theoretical power, it is Tt into N. Here care should be taken, because the value of N should be in radians per second. So the value of N, what we have identified, is in revolutions per second. So for the value in revolution per second, to convert it into radians per second, we have to multiply the value of N in revolution per second by 2 pi. Means to say that Tt into N, Tt is 91.4 Newton meter here, followed by 7.32 is the value of N in revolutions per second. To keep the value in radians per second, you have to multiply by 2 pi. So upon the conversion or upon solving, we are going to get the value in watts, that is 4200 watt. If we convert it into kilowatt, it becomes 4.2 kilowatt. Okay, so do remember, you have to concentrate first on the given data into standard unit, followed by you have to keep the value of N in radians per second only when we are targeting the value of theoretical power, whereas in rest of the cases N will be taken into revolutions per second or revolutions per minute. Now let us move on to the next topic, that is hydraulic motor efficiency. As like what we have studied in hydraulic pump, here also we are going to study 3 efficiency parameters that represents the value of the type of motor. Okay, so first one being volumetric efficiency. It is defined as the ratio of theoretical flow rate of the motor to the actual flow rate of the motor. See, the value differs as in case of pump here, because based on the working principle. So we define the efficiency in case of the working principle here. So please never confuse with the equations of the volumetric efficiency of pump to that of volumetric efficiency of motor. Okay, so here it is theoretical flow rate of the motor divided by the actual flow rate of the motor. Next, the second one, the mechanical efficiency. Here it is the ratio of actual torque delivered by the motor to that of theoretical torque what it is being delivered by the motor. So it is TA by TT. And finally, the overall efficiency, it is the multiplication or the fact of volumetric efficiency into mechanical efficiency. So considering these parameters, let us go on with a numerical solving for the understanding of efficiency parameter of the hydraulic motor. So you can just go through the question here. A hydraulic motor has a displacement of 164 centimeter cube and operates at a pressure of 70 bars at a speed of 2000 RPM. If the actual flow rate consumed by the motor is 0.006 meter cube per second and actual torque delivered by the motor is 170 Newton meter, find number 1 volumetric efficiency, number 2 mechanical efficiency, number 3 overall efficiency, and at last actual kilowatt delivered by the motor. So here the first point what we are supposed to do is take the given data in SI unit. See, the volumetric efficiency is, volumetric displacement is given 164 centimeter cube. We have to keep it into meter cube per revolution. As I already said, if the value is given in centimeter cube, we have to understand it as centimeter cube per revolution. So we have to convert that into meter cube per revolution, which is converted here. That is 164 centimeter cube converts into meter cube, means it is 0.30164 meter cube per revolution. Followed by the pressure is given, operating pressure 70 bar. It has to be considered in Newton per meter square. Hence it is 70 into 10 raised to 5. Next is N given RPM, that is 2000 RPM, it is accounted here. Next is actual flow rate is being given of motor, that is 0.006 meter cube per second, and followed by the actual torque is given TA, that is 170 Newton meter. Now we have to go with the identification of 4 parameters, being one first is the volumetric efficiency. We know volumetric efficiency is QT by QA here, so as it has been defined. So we know the value of QA in the given data, but we don't know the value of QT. So hence first we have to identify value of QT. So QT is given by VD into N. So VD is known 0.000164 meter cube per revolutions into N, that is 2000 RPM. The standard unit for the flow rate is meter cube per second. Hence, the value of RPM is converted into RPS here. Hence, it is 2000 RPM is the given. Divide by 60 gives you value in RPS, that is revolutions per second. Hence, the value of QT becomes 0.00547 meter cube per second. Now substitute the value of QT here. We know the value of QA. It is 0.00547 divided by 0.006. So the volumetric efficiency of the motor is 91.2%. Use calculator and verify the solution. Followed by the second parameter to be identified, that is mechanical efficiency. It is TA by TT here. TA is given 170 Newton meter, but we have to identify the value of TT. So that value of TT is identified using VD into P by 2 pi. We have taken down the equation for that. So substituting the value here, direct substitution, you will get the value of TT, that is 182.8 Newton meter. Substitute the value of TT in the equation to identify mechanical efficiency. We are going to get 170 divided by 182.8. Hence the value becomes 93%. See, the value what we get will be in terms of number. We have to convert that into percentage by multiplying by 100. Okay, so followed by the overall efficiency here. So overall efficiency is volumetric efficiency into mechanical efficiency. So direct substitution, you are going to end up with the overall efficiency being 84.8%. Now comes the task of identifying the fourth parameter, that is actual kilowatt delivered by the motor. That is nothing but the actual power. Whenever we are going to identify the value of power, keep in mind N should be in radians per second. Okay, so the actual power is TA into N here. So TA is known 170. N is in RPM here. That is 2000 RPM. To convert it into radians per second, we have to multiply it by 2 pi and we have to divide it by 60. That is, so 2000 divided by 60 becomes revolutions per second. Multiplied by 2 pi gives you the value in radians per second. So whenever we are targeting the identification of power, keep in mind N should be in radians per second. So upon substitution, you will get the value as 35,600 watts, and converting it to kilowatt, it becomes 35.6 kilowatts. So here, whatever numerical will solve, it is all the direct substitution, and we have to basically consider the conversion factor of given data into the necessary SI unit before substituting in the actual equation. Now, let us study the last part of module 2 in fluid power system, that is graphical symbol or symbolic representation of hydraulic actuators as well as hydraulic motors. So here, the way wherein which we started our study with the module 2, there itself we will be considering the working principle and the spontaneous representation of graphical symbol for the hydraulic actuators. So we have two types of hydraulic actuators, single acting and double acting. In case of single acting, so we have gravity return type and spring return type and telescopic type. So telescopic doesn't have that amount of graphical representation because it consists of the entire construction itself to be the graphical symbol. So here, this represents the piston and piston rod wherein the additional load will be carried, and we have only one port that results in the extension of piston, whereas the retraction is basically due to the gravitational force or the dead weight of the piston. Hence it is gravity return type. Here the retraction is basically concentrated on the spring force which is compressed when the fluid is being taken in to the actuator. Similarly, we have double acting cylinder. So the basic difference between single acting and double acting is that in case of single acting, only one side movement will be controlled by the fluid pressure. That is, extension will be controlled by the fluid pressure, retraction will be taken care by the other means. Whereas in case of double acting cylinder, both extension and retraction will be considered by the pressure of fluid which is being fed into it. Okay, so we have different cases in case of double acting cylinder as well. So we have taken few, that is differential type, means to say that the piston consists of piston rod only on one end. Okay, so we have inlet and outlet. So this is the graphical symbol for this double acting cylinder with differential type or one end piston rod type. So we have non-differential type, so wherein we get the accessibility of the piston rod on both the sides of the piston. Okay, followed by the cushion. So this is one particular representation that represents the assistance of end cushioning in the actuator. And one more type, pressure intensifier, that consists of piston and piston rod end, and which results in increase in the pressure of fluid, and this is the symbolic representation for pressure intensifier or intensifier for double acting type of actuator. Okay, so moving on with the hydraulic motors or the rotary actuators. So we have different categorization to represent here. So keep in mind, a triangular portion with a shaded representation represent the hydraulic motor. If it is empty, it is taken to be pneumatic. Okay, so we have unidirectional represented by a rotatory actuator by a circle, followed by the triangle, inverted triangle with shaded part, and we have reverse rotational of unidirectional. So we'll be having a representation on the opposite side as like here, and we'll be having a variable displacement type wherein the existing motor represented with a cross line with arrow headed, it is represented to be variable displacement. Means to say that if we don't have any line, it is fixed displacement rotary actuator or hydraulic motor. And similarly, variable displacement reverse rotational unidirectional. So for this reversed rotational unidirectional motor, if we have a cross line with arrowhead, that becomes variable displacement. So again, we have bidirectional fixed displacement. For unidirectional, if we add one more triangle, which upright triangle with shaded part, that represents bidirectional. And for the same, if we have a cross line with arrowhead, that represents bidirectional variable displacement type. And similarly, we have one special case, variable displacement motor in one direction and pump in another direction. So this is the representation, and the last one being limited rotation motor, as we have stated in the study on hydraulic motor, theoretical torque, power and flow rate. So that is the limited rotation motor. See, this is the complete syllabus completion for module 2 in fluid power system, that is 17 MS 72. Okay, so here the few of the areas wherein you have to majorly focus is on the construction of different types of actuators and motors. Its working principle should be briefly written in case of your exams or in case of your internal assessment, followed by the numericals wherein we are going to consider the standard units to consider the exact parameters or the solving of given data. Thank you.